Okay, guys, I'm not going to go over these. You should be able to do that now. Um, and I'm not going to go over these because you should be able to do those on your own. But I will go over all of these. So vertex, this should all be fine, right? Except for maybe the y-intercept. So let's do that. So the y-intercept, this is y equals x plus 4 squared minus 3. The y-intercept occurs where x is 0. So y equals 0 plus 4 squared minus 3, which is 16 minus 3, which is 13. There's the y-intercept. The roots occur where y is 0. 0 equals x plus 4 squared minus 3. 3 equals x plus 4 squared, square root both sides, plus or minus root 3 equals x plus 4. So negative 4 plus or minus root 3 equals x. So that should be good enough to get you through all the rest of it, but of course we will go on, carry on. Y equals negative 0 minus 2 squared plus 1. Negative 4 plus 1 equals negative 3. And 0, I'll change color, sorry guys. 0 equals negative x minus 2 squared plus 1. Negative 1 equals negative x minus 2 squared. 1 equals x minus 2 squared, square root both sides, plus or minus 1 equals x minus 2. Bring the 2 over. So 2 plus or minus 1 equals x, which is 3 and 1. No roots because it's a sad parabola below the x-axis because it goes, the vertex is right there at negative 6 and it goes like that, so no roots. This one is its vertex is at negative 8, positive 6 out here, and it's a happy parabola, so it goes up, so no roots. This one, okay, let's do these. So what I do with that is I need to put it into this form. So that is complete the square situation. Y minus 18 equals x squared minus 10x plus 25 plus 25. Y plus 7 equals x minus 5 squared. Y equals x minus 5 squared minus 7. So there, and then I just do the vertex of this. Vertex equals 0, 0. Vertex here equals 5, negative 7. So it went that way, 5, and down 7. No stretch. Good spelling. No stretch. And it's happy. Come over to, or down to B. Get rid of that. Again, complete the square. Y plus 7 equals negative x squared minus 4x plus 4. So I added negative 4 to both sides. Plus 7, half of that is 2, 4, yep. So I did negative 4 to both sides, so that's y plus 3 equals negative x minus 2 squared, which is y equals negative x minus 2 squared minus 3. So my vertex, my vertex went that way 2, down 3, sad parabola, and no stretch. Come over to here. Y minus 5 equals 3 x squared minus 2x plus 1. So I added 3 to both sides, plus 3. Y minus 2 equals 3. X minus 1 squared, y equals 3. X minus 1 squared plus 2. My vertex went that way 1, up 2. Happy parabola, and y is multiplied by 3 because of that stretch factor. And this one, y equals, oops, sorry, and I'm working in blue, y minus 20 equals 1/4 x squared plus 16x, because 1/4 of 16 is 4, plus 64. So I'm adding 1/4 of 64 to both sides, which is plus 16. Sorry. Yeah, plus 16. So, because this is a positive parabola. On your key, I wrote that as a negative parabola for some reason when I went over this. So make sure you watch this. This is y minus 4 equals 1/4 x plus 8 squared. So y equals 1/4 x plus 8 squared plus 4. So my vertex is really that way. I lie. My vertex is that way 8, and that way 4. It's a happy parabola, and the y is divided by 4 because of that stretch factor. I'm just looking at my paperwork, and yeah, I said that was negative there. I don't know why I did that. Probably because that was when I was in a room full of grade 9s. This one, I call it calculator practice, so let's go ahead and do that. This is the formula you have. Now you have to use y's and x's. So it's y equals negative 5x squared plus 20x plus 2. Excuse me. So I can punch that into my calculator, which I'm going to bring up on the screen because I called this calculator practice. So I go to y, and I do negative 5x squared plus 20x plus 2. And I graph it. Now, it showed right there, little, no good. So I'm going to change my window, of course, to, I only need positives, right? So let's change it to 10 seconds, x scale of 1, and it's, let's go, our y scale of, our y-intercept is 2, right? So let's say a y max, well, let's leave it at y max of 100, and let's say it's 10 and see what we get. That'll do. So now I needed my maximum height. So A is my maximum. Second, calc, max, left boundary. And to get down to the other side, here comes my cursor. No problem. Bonjour, Madame Gray. Ah, ça va bien. Left boundary is entered. Oops, crap, I just hit graph. Text, calculate. Left boundary is entered. Right boundary is entered, I guess 22. So 22 meters. B, from what height was the arrow shot? Well, that means your time is 0, right? So I need second calc. My value is x equals 0. So y is 2 meters. And how long did it take for the arrow to hit the ground? So that is when height is 0, so when y equals 0. So there's my graph. This is 2 because it goes from there. So it's right here where y equals that, right? So that is a root or a 0 of the parabola. So I go here, not y, second calc, 0, 2, and I get my left boundary. Here it comes. Enter. And then I just go past till I'm off the screen or past where I want to be. Enter. Guess. No sign change. What was wrong with that? My window was no good. So I go to my window. And I'm going to give myself some negatives now so I can get that left boundary. Negative 10. I'm going to regraph. Now I can see that left boundary there, yes? So second calc, 0, left boundary. There's my cursor. It's to the left of the 0. Enter. Now I go to the right of the 0. Enter, enter. And I get 4.09, right? Which is going to be 4 seconds. Now, when I did it without a calculator, I told you guys it was 2 plus the square root of 4.4, which makes sense because the square root of 4.4 is basically 2. 2 plus 2 is 4. Factoring. I don't feel I need to go over factoring, except maybe the, yeah, I'd better go over these. So let's get rid of that. Okay. A. So this is 2a squared plus 11a plus 14. And then you factor it normally, right, to get 2a plus 7 and a plus 2. That's going to get you 2a squared plus 4a plus 7a plus 14. Then here you plug this in for a. So it's 2 times x plus 1. So that's 2x plus 2 plus 7, which is 2x plus 9. And then this one is x plus 1 plus 2. Sorry, x plus 1 plus 2, which is x plus 3. And that's how you get that. And then you do the same thing here. That's a and that's b. So this is 9a squared minus 4b squared, which is 3a minus 2b, 3a plus 2b, and then you just sub these in. So this is going to be 3a plus b, minus 2b, 2a minus b. That's the first one. And then the second one is 3 3a plus b minus, or sorry, plus, because I did minus first, 2a minus b. And then you just expand it. 9a plus 3b minus 4a plus 2b, and 9a plus 3b plus 4a minus 2b. Then you collect your like terms. 9 minus 4 is 5a. 3 plus 2 is 5b. 5a plus 5b. And 9 plus 4 is 13a, and 3 minus 2 is 1b. And then the rest of these are regular factoring, so I don't think I need to go over it. This one, I would like to go over it. Again, you could use your calculator, or you don't need to. The theater has to look like this, right? Rows, and each row is divided into seats. So, and there's 285. So row times seats equals 285, right? But we know that rows also equals, right here, the number of rows is 4 more than the number of seats. So rows also equals seats plus 4. So that means that seats plus 4 times seats has to equal 285. So s squared plus 4s has to equal 285. So s squared plus 4s minus 285 has to equal area, or whatever. Doesn't matter. Call it y. And then that can go into your calculator. So I go to my calculator, I graph it, clear, on, clear, clear, go into my y values, clear that, and I know it's x squared plus 4x minus 285. And I graph it. Now that's going to use that weird window that I just had, right? Not even going to fit on there. So I change my window to, doesn't really matter, you got to think about it. I can't have 0 though, right? Can't have negative amounts of seats, so we'll say 0. Let's make our maximum 50 because it doesn't matter, and let's go by tens. And let's keep our y's at 0. Well, we may want a 0, so let's go negative 10. And let's take our y max up to 100, it doesn't matter, and let's graph it. Didn't really work for me, did it? I've got a 0. That's no good. So I go back to my window, change my window. All right, let's go to an x max of 100. Let's go to a y max of 500. Let's get our y scale at 100. Well, I got the beginning of it. So I'm having trouble setting up my window because, you know, that's probably what's going to happen to you guys. So let's try it. If you have trouble setting it up with your window, you can always go back in quadratic formula. But I do want you guys to get a little bit of calculator practice, right? So let's check our 0 here. Second, calc, 0. Here it comes. There, it's on the left because I've dropped below 0. And it's on the right. So my x is, oh, see, that's no good. I've screwed this up somehow. We should be okay to here, right? So what did I do wrong here? X squared plus 4x minus 285. I don't know what's happening there. I don't really have time because I got some other stuff to do. So I'm going to go from here, and I'm going to show you quadratic formula ABC. So this is S equals -4 opposite B plus or minus the root of 16 minus 4 times 1 times -285, all that over 2, which equals -4 plus or minus the root of 1156 over 2, which is -4 plus or minus 34 over 2. Now, can't be minus, because that would give me a negative, right? So it has to be the positive one. So that becomes 30 over 2, which equals 15. Once I have S as 15, R equals S plus 4. So my R is 19, and my S is 15. I don't know why that didn't work on the calculator. I don't know what I did wrong. I'm going to quickly go back and check it once and see if we can fix it up. X squared plus 4x minus 285, graph it. X squared plus 4x minus 285, graph it. Let's change our window to, actually, let's see what happens if we go zoom standard. It's not there. So I'm going to change my window. I'm going to change my window to an X max of 20, because we know it's 15 now, and I'm going to graph it. There it is. It's coming right through there. Second, calc, 0. My left boundary. Should be coming up here. Oh, there it is. Enter. My right boundary. There it is. Enter. 15. Worked that time. Don't know what the problem was. So there we go. And finally down here. This one you really need to use your calculator for. I'm going to be doing some coloring here. This will help. This right here is what we don't know. So that's X. This has a radius of 1. So the whole thing is X plus 1. That's my radius. Now, I know that the top area is 63.6, and I know that area of a circle is pi r squared equals area. So I have pi times x plus 1 squared, because that's my r, equals 63.6. Now I just do math. X plus 1 squared equals 63.6 divided by pi, which you would do on your calculator. 63.6 divided by pi. Then you would square root both sides, equals the square root of 63.6 over pi. Now, why do I only want the positive one? Because this is a distance. So x equals the square root of 63.6 over pi minus 1, which is 3.5. Now, if I'm going to do this on my calculator, like I said, I'm going to come in here. My y, clear, is right here, yes? So right here on my calculator, right here, it's got to be pi x minus 1, x plus 1 squared minus 63.6 equals y. Now I put that into my calculator. So second, pi bracket x plus 1, close brackets, squared, minus 63.6. And I graph it. Now I don't need the negative, I only need that 0, yes? So second calc 0. And then I just sort it out. Left boundary, there I come. Left boundary, enter. Right boundary, enter, enter. 3.4999, so it's 3.5. And I think that's it, isn't it? Oh, no, 2 more, a couple more. Name the method. So I did that in class. I solved it to get my roots. B, I factored it to get my roots, factored to get my roots, factored to get my roots. You guys know how to factor. I'm not going to go over that again. And this was the discriminant, just to go over it. The discriminant is b squared minus 4ac. B squared is 36 minus 4 times 1 times 3. 36 minus 12. Positive 2 roots. And then you should be okay.